So I am going to present now this land degradation issues. I have spoke in a greater detail before that it is a global environment change issues and it has multiple implications for deforestation and land degradation, soil degradation, and desertification and many more. Let me give a brief insight about we can study land degradation in a number of ways. So let me have a little bit of methodological grip. And also land degradation can be studied in a linked context, not in isolation. As we have already seen, land degradation has an important implication for biodiversity loss, and also land degradation has an important implication for various different kind of other ecosystem processes. To say that, we can study the land degradation by studying the impact of this land degradation on different processes. For example, when land is degraded in the above part of the terrain or in the uphills, what happens is soil comes along with it, soil get eroded and get deposited, and also in the water bodies, it get deposited. That is called sedimentation. So sedimentation is an impact of land degradation. So if you want to quantify land degradation, you can quantify the sedimentation rate, as also you have seen in this picture. Land degradation also, the impact can be studied by studying the impact on ecosystem services. I have given you that different type of ecosystem services that the soil provides, the provisioning services like providing food, shelters, and so on. Land also provide the regulatory services like biochemical cycling of nutrient. It also provides cultural services, the different kind of other spiritual ecology related to the landscapes. So whatever impacts it happens on those services, also we can study the land degradation from that kind of perspectives. But all in all, very many different kind of soil function when the earth began, when everything, the civilization was possible, when human being came to this world, all this was ready-made thing for the humanity. And just mythically or just using it for fun, a wisdom tradition, human become over smart and challenge the nature, and they have to now face all the problem in the Garden of Eden. Okay, so all these soil delivers ecosystem services that enables life on earth. Only when you do intervention, when you do some kind of anthropogenic influence on, for example, soil carbon sequestration, all the purification path of the metals and toxic element in the soil by constructing many kind of concrete structure, road, parking lots, and so on. When we destroy cultural heritage for the benefit, economic benefits, and so on. So many this kind of thing in a way when we impact the ecosystem services, when we impact different kind of processes like sedimentation, humidification, aggregation of soil, then that way we can study land degradation in greater detail. Other thing is what kind of practices the different farming community around the world follows. For example, in Nepal, when before they even clean the land for cultivation, they should have been doing some proper terracing work, but it comes afterward. And therefore, when the rain comes, they have removed the vegetation, there is no proper terracing, and then a lot of erosion happens that way. And also plowing on that land, barren land which is exposed to the rainfall, they also start plowing, and then each plow become a kind of path for water to flow and creates a real erosion afterward. So all in all these kind of different soil degradation processes, which are some are physical, some are chemical, some are biological. And if you look at all these different things in detail, whole world, without shadow of doubt, is undergoing land degradation. So global status of human-induced land degradation, if you look at the yellow and red, this is everywhere. You see, so this is why it's a global problem. Let me just bring you a little bit about the little mechanism. Take an example of land degradation through soil erosion by water. When you have removed the erosion, soil cover by deforestation and very many other things, not maintaining the cover crops in the plant, in the field, cover crops plant in the field, then the rain, when it's coming from the sky, is directly hitting to the ground because there is nothing above which is anyway intercepting that rainfall. You know, all these trees, for vegetation, raindrops coming from the sky is nothing but kisses from the heaven. But when they have been chopped, there is no one to love that raindrop, so it's directly fall into the barren soil and create something called splash, then splash, and that itself is detach the soil particle, as you can see in this picture. So beginning happens that way. And then the sheet wash, the sheet means the uniform removal along with the rain. But then because of the different terrain, the water get concentrated in their flow pathway and forms a small finger-like incisions, like a small finger-like ditches, as you can see in the photo here. So that is a real erosion. And when the real erosion becomes bigger and bigger, so you can see it here. In the beginning, sheet, the uniform removal, and they become a small finger-like incision here. And when this finger-like incision become more than 30 centimeter depth, then they become gully. And when this gully become bigger, then they become channel erosion. So this is just an example here photographically, as you can see, and this is happening around the world. So this is one mode of land degradation. I mean, erosion by water, and as you can see it here, this channel erosion, when the big this kind of land happens, the land, when you allow erosion to grow and grow bigger, the land restoration becomes increasingly difficult and requires a lot of resources and money for that. For example, after, if you don't do anything with the gully, then slowly it further develops to channel erosions, and all you see land is getting impoverished, and the vegetation are also gone. And in the long run, they will look like a desert-like condition, the desertification. This is an example here. In fact, when you are losing soil, you are also losing nutrients. Not only soil. In fact, when African, South Asian, many people are producing their vegetable, grain, fruits, and that we import here. Together with that fruit, that vegetable, that grains, nutrient also comes along with it. And then it doesn't go back, you see. So either it is gone by soil erosion or topsoil losses or through nutrient harvest, okay? Only if you look through NPK loss through topsoil loss data, you see that is a vast area, the harvested area, and how much soil is lost, million tons per year, very high in China. And this NPK, these nutrients, which you need. If it's deficit in soil, you need to buy in terms of fertilizer and apply it. So that has a cost, and you see that so much of cost for replacing that. So this is what we need to also keep in mind when we study the global land degradation, what kind of dynamics is taking place. Now, the immediate cause, if you ask what is the immediate cause of land degradation, immediate means the proximal cause, okay? That you just, in a very short-sighted way, you can just, okay, there are a lot of animals were grazing there, therefore this land is degraded. But who was making decision to allow this animal to graze there? What is the current capacity of that land? Who makes the policy? That's altogether is an underlying variable. It's not a immediate but underlying variable. Just this is one example of these numbers. You don't need to really think more upon it. But overgrazing, as I have already said it in the earlier lecture, the deforestation, large scale lodging, the almost 250 hectares of land is degraded every minute. Land is deforested. That is the deforestation rate. Agriculture damage through water erosion. So, and this is also a lot of, these data are all continuously being updated. Also, rate of salinization, particularly arid and semi-arid areas, and also because of intense rain and it's drying out. What's called climate extremes are also growing. Fuel load, farmer needs these biomass from the forest in order to cook their food and for their survival. And when because of the fuel load demand, if there are no alternative sources of energy, then also that contributes to land degradation. And industries and urbanization. Every time these cities are growing, they are encroaching the land nearby. The cities are built on the land, not in the skies. Can you imagine let's imagine in the Os area where we live. When I came to Norway, let's say 33 years ago, not these parking lots were not many were there, only few were there. So now you see everywhere this parking lot and huge number of cars. Can you imagine a little bit what has happened to the soil below that parking lot? What happened to microbial community which were functioning very many things around it here? All will be dried out, isn't it? It will be a lifeless pocket that we are creating in the land through urbanization and infrastructure. Some basic idea about the deforestation. Deforestation is a temporary or permanent clearance of large expanses of forest for agriculture and other uses. Okay, our forests are being deforested almost 89 million acres or 39 million hectares from 2000 to 2005, but this is being again updated. Many regions, fire is also forest fire. You see recently in the California, that side, in Australia, not many months ago. It's those kind of incidents of forest fire are increasing very globally, and it becomes a global force now for the deforestation. Expansion of agriculture, because population is growing continuously without a sign to slow down. So the agriculture also need to be, you have to make extension of agricultural land. Otherwise, where there many is that 80% population who are living in developing world, developing world, where they have to also find their food by expansion of agriculture. Construction of road, every nation has their own development path. Road construction is a great sign of development, this and that. But now I think this transport, this communication, this and that, this COVID-19, we need to think what is a meaningful, realistic, and homegrown development that is more sustainable. Okay. The result of deforestation is, of course, when there is a deforestation, there is increased soil erosion. Therefore, the nutrient is washed away. Therefore, decreased soil fertility, uncontrolled soil erosion because you have removed the cover, the rain is directly falling on the top. There is also bearing on the production of hydroelectric power when land is degraded, very much of silt, the siltation of this hydroelectric dam and so on, increased sedimentation of waterways. You can name them and name. So, but it's very context specific. Remember, land degradation is not one general phenomena. You have to look case by case. Where is the place? What type of soil? Maybe some soil are more inherently, uh, this inherently this is prone to land degradation. Some soils are easily compacted by tractor traffics and some are not. So we have to look at. But in the context of Himalayan region, which is a hot spot of land degradation, let's take one context of Himalayan region here. This is a Himalayan region. This is already a weak mountain and already a fragile ecology. There is already high potential for degradation, steep slopes, unstable geologies, short period of heavy rains, high speed winds, flooding, drought, all these kind of things happens. So there is already a naturally more prone to land degradation, okay? Therefore, we need to have an extra land care around it. And then in this, Himalayan region, almost more than 400 million people are living. That rapid increase in the population and livestock populations, and also there are very many, you see in this photo also, on sound practices. This land would have been some kind of cover crop, and also uncontrolled and excessive grazing, poor management. This is what happens here in the Himalayan region. Also setting, when you are making a shifting cultivation, they are also setting fire to the forest, and also environment, unsustainable infrastructure. And other thing is the land fragmentation, this macro polity related factors. Land ownership become unplanted urbanization, on-plan type of organization, and inappropriate land use practices. For example, in Nepal, in India, land can be divided. Like if a family, parents have half a hectare of land in their position, and then if they have 6 children, then that is, the division of property when they die. So and then when this already small piece of land is further divided, it becomes first of all economically unviable. Other one, everybody has to grow all vegetable and every food there, so it's intense pressure on the land beyond its capacity. So in that way, Norwegian land use classification and land use system is very good. Few words about land degradation and population. Always we should not blame population. High population density is not necessarily related to land degradation. It is what population does to that land and determine extent of land degradation. Like in this monolith in the Vigeland Park, in the central, when every people want to survive in any way by pulling this and that, and there is no kind of other kind of concern, the survival race, then of course people from like in Nepal, from the hills, they come down to the lowland, the flat land, and they attack forest from 10 different directions and try to be the first to grab certain amount of land, and also motivated by the politician and so on. But people can be a major asset in reversing a trend toward land degradation. However, they need to be healthy and politically, economically motivated, also environmentally motivated to care for their land. Of course, there is a relationship between the healthy soil, healthy land, and also because healthy food comes from a healthy soil. If soil is impoverished, unhealthy soil quality is gone, then you cannot grow food. You may have a little choice. So we'll talk more about this and human health, global human health and environment. So healthy soil will give healthy food. Healthy food will bring a pool of population, the people which are likely be more healthy. Healthy people means healthy society, okay? And they become more productive. There are 1,000,000,000 new issues which are coming when it comes to land degradation or soil degradation. Even this new threat, microplastic in soil, the plastic is thrown here and there. In this way, this is a really new issue, and this plastics goes to both physical and chemical factors. This small, depending upon the size of plastics, it comes to our food chains. We need to look at in more greater detail. Few words about method for assessing soil degradation. Well, and there are very many different methods that we have been following in past: expert reviews, long-term experiment, official production of statistics, that some kind of empirical model or processless model that the FAO uses, and try to find out a gross estimate of land degradation around the world, and also do the experiment and with the farmer plots in the farming conditions with a different cultivation history, maybe that patches of land where the farmer is growing in a monoculture way, in a more nutrient mining type of crops like maize and so on, that patches of land will be impoverished soon than other which contains legume. So we need to also know the cultivation history, the nutrient balance studies, how much crop crop and harvested product is taking away the nutrient from the field, and how much you bring it back through fertilizer and other way. If there is a net higher output of this nutrient which goes away, farmers are growing vegetable, this, that, nutrients it takes with this, and all from Kenya, many vegetable comes to Norway. It never goes back. I mean, we eat here and it goes to our toilet. Okay. So there in Kenya, they need to really balance out what goes away, long away from them. So monitoring soil depth is also another one that we have been using with our student, over a period of time. There are erosion plots. We do the siltation trap studies, also look at the soil properties and so on. And there are also some advanced methods which are not available so much for developing countries, but at least here in Norway, we also use a very sophisticated method. But each of the methods, when we assess the land degradation, they have an advantage, they have a problem, they have some kind of limitation in which scale we apply. For example, expert opinion in the difficult terrain in Nepal and many places, it's not at all. I mean, it's extremely difficult to do some kind of plot study. So those people from there, expert, and also in combined with the indigenous knowledge, indigenous expert, we can see at least more subjectively way, but we can apply in a very larger scale and potential for all scale. Okay, we can say that grossly the hills of Nepal are very much degraded. Hills of Bhutan are not very much degraded because they have maintained the vegetation that way. So expert opinion, and soil, vegetation, and water bodies, we can expert can say their opinion. Remote sensing is fairly rapid. Okay, it's applicable in low access areas, but because of what the remote sensing from the satellite from the sky, the information we get it is not to that detail at a plot scale or a small scale. It gives you information about what is really happening there. So it is good, but it is very good for the national, district level or regional level kind of mapping. Let's say vegetation cover, decline in the vegetation cover from the space. Also vegetation density and cost is also relatively low because You don't need to, do a kind of too much of a field experiment in this one. Field monitoring that I was doing together with my student is cost is really high because you need to measure each plots. You need to have this erosion, the soil trap kind of structure there, and then over a period, every rain event before that, after that, you need to quantify how much soil is being washed from up and deposited in your trap, and then you have to weigh them. Okay, so it's a direct methods, and then it requires a lot of, we had a very big problem to carry all this trap in a difficult terrain in Nepal. But of course, it gives you the actual data of that time point again. So you need to have there are also temporal variability in the weather conditions, rainfall, and accordingly, you need a little bit long-term data. Productivity change is another one where how was the yield before, how is yield now? Also, there are other methods like field criteria and talking with the farmers. This is also slowness and subjective kind of information that you get it here. Uh, so there are modeling also we have been using very heavily in our research. But this is again how you have calibrated that model, universal soil loss equation, revised universal soil loss equation that we are using even in the Nepal and South Asia. In Europe, there are many other models like LISEM model developed by European, and every model have their own you need to calibrate, and we need to measure those parameters and the field validation and calibrating the model all the time in a different context. Okay, so that's very important. Well, in the global context, global land degradation assessment program, this LADA, just for your, there are international initiatives, land degradation assessment in dryland. This provides very many periodically review and synthesis of data, also brings some kind of new development and testing methodologies, also doing some kind of work in a more integrated way with some controlled pilot studies. There is also GLADA, Global Land Degradation Assessment. This also, but so whole when they collaborate and so on, using very many different ways, they time to time this extent of and severity of land degradation in they are making this kind of map just for an example. So one live example, this is the work that I did together with my PhD student in the hills of Nepal in the Maudi watershed. This is the watershed, and then we use the universal soil loss equations to really, based on the slope, the terrain, there are many things, the rainfall data and type of vegetation here, the conservation practices they have. There is that itself is in order to learn that you need to, it's an entire course in the master in soil science, but just to give you an results from that one, this is the watershed. And as you see that in the different patches, and depending upon what kind of slope, whether vegetation cover there is now some slope are red, means a high, the magnitude of soil erosion. But what is most important message is that you should not rely on model if it's not calibrated in that, because as I said, it is very context specific, this soil degradation kind of thing. In this work, you see, this is the green one that we have measured from different land uses. Upland maize and millet system, the rice system, the menace forage and grazing. The one that we have measured in the field are significantly lower than what model predicts, because model is not able to capture. Of course, the relative numbers are more or less okay, but it's overestimating because maybe that there are some complex, the terrain and biospheric kind of interaction there. So we need to calibrate this model using this measure data to make it more robust. Also, we need to, when it comes to land degradation, even the soil is washed from the upper terrace, it is getting deposited in the next terrace and so on. And we need to know that detailed dynamics before actually we can predict it. This is another exercise we did in a very biodynamic economic modeling. Is a huge modeling exercise that we have published in 2005. I don't have time to go into in a greater detail, but the causal, the correlation that we have established in very many other research are when population is growing, when the prices of their crop is fluctuating, and also there are other kind of technological issues which are there. Based on that, there is a bearing on soil loss, total soil loss at the watershed level. So then what we have seen is that over a period of time, and this is true, we started this work long ago, soil erosion is growing and growing, because you can see that every year how much soil is washed by this river, perennial river in the Himalayas. So if the yield is, if there is a technology that increases the yield of their crops, then the assumption here is that when the yield is increased, their income will also increase, and with their increased income, they will not be, they will try to get a alternative energy sources like the gas or other sources than the fuel wood. Therefore, but still in that scenario also, when you increase the yield, it becomes slightly less than the other scenario, but trend is more or less the same. So like that, the price, if the yield is increased, but if at the same time the price, if they get a good price, same kind of assumption, when they get a more income by increase not only the yield but the prices of the crop, this also slightly, compared to this, without price constant, this is less, but still you see the trend is more or less getting high. So if you combine all these different agriculture technology, economic incentives, population control, and so on, this is yellow mark, and that you are able to significantly reduce, but still the trend is, because we have also a natural background rate there. So it's a challenge to keep this land and food security alive. Okay. So as we know that we have to look at land degradation from very many different perspectives. Okay, not only from the physical soil loss per se, but provision of agro-ecosystem, the added benefit to biodiversity, reduce greenhouse gas emissions from agriculture, deforestation, okay, reduce vulnerability of agro-ecosystem. So there is a linkage here. So what is most important here is that today land degradation, historically in my time when I took my master degree in 1987 and so on, we are just studying land degradation in isolation, biodiversity in isolation, climate change in, that was not even climate change issue has not that much in a mature that time like today. Okay, but these three already in 92 onwards, they become that we need to see in a linked context, because if the land degrades, it degrades biodiversity, because the land is a habitat for the biodiversity. When land degrades, water degrades along with it. Okay, and when land degrades, that means that land is more exposed to the oxidation and the churning of the soil. When the land degrades, forest will degrade, and so forest degradation means less sink for carbon dioxide. That means more CO2 is left, and there will be climate change. So that is, and then if you look at the other studies, if you in isolation examine what is the effect of land degradation on that particular ecosystem process, you get one number. And keeping other things constant, if you only examine what is the effect of climate change on that particular ecosystem processes, you get one number. But if you look at the interaction effect, what is the combined effect of land degradation and climate change? It is, combined effect is more greater than the sum of individual effect because of this interaction. Okay. So that is what is called synergies. In the synergies, 2 plus 2 is not 4. 2 plus 2 could be 5 or 6. That we need to know. That's why we are linked here. Okay, so here is a simple impact matrix, which shows that which area there is a lot of work that is been available and which area best recognized linkage is there and which area which need more uh, other kind of feedback loops. And for example, effect of land degradation on biodiversity, this green one is very much recognized and well established, okay? And also there is a lot of good feedback loop on land degradation and further land degradation of that area. But effect of land degradation on climate change is still a long many study we need to do. So like that, this matrix shows that in which area you have a possibility to generate more project when it comes to land degradation. So what I'm saying is that all in all, let's say one example. What is the effects of land degradation and climate change? When land is degraded, the lighter soil colors becomes, and then it is a lot, in a greater degree, there is a more reflectance because albedo increases of the soil, okay? And therefore, when things is just being reflected very quickly, then there will be this undergoes more trapping of this. Also depletion of soil carbon. When the land is degraded, carbon is depleted in forms of carbon dioxide and they go back to the air and it increases the temperature. And in such area, when land degraded area, there are also extended drought. Drought is also an issue of the climate change. Land degradation and biodiversity, because obviously soil biodiversity both above and below. This is the soil, the land is the habitat and habitat is destructed, it will affect the biodiversity. Like that, climate change and land degradation. So these things that you need to read in a greater, very nicely, very simple, easy reading material in the your paper reading material that is then, okay? So biodiversity and land degradation, that means mainly through the land use changes, mainly shifting cultivation means clearing above ground the biomass, okay? And then that means along with when you clear it, the habitat for the birds, habitat for many other things, animal which is dependent on that will be also degraded there. So this is a overall causal linkage today. Today, if you ask, I wanted to study what is the effect of land degradation and such thing, very difficult to get funding. But if you relate that land degradation have a causal linkage and feedback loops and so on with other two major global environmental change issues like biodiversity loss and climate change, using this kind of linkage, and this has been further developed, that you are able to get your case justified, because all this linkage is based on very many published paper, okay? And it's not very difficult to understand. For example, how climate change will affect land degradation. As you can see this loop here, climate change means increased atmospheric carbon dioxide, either by fossil fuel or something, but the climate has changed. That means that increased temperature and evapotranspiration, increased water use efficiency by the plant, and then this will have a bearing on the land degradation, okay? When quickly water is drawn from the soil become dry, and slowly the amount of dust increases because of the drying of the soil and so on. So like that, you can make some kind of linkage in this graph, which is there in the paper. Other thing is that in order to be operational, you need to know a different label, like here. What are the driving forces? The economic policy, that may not be sound. Land use development plan is not very sound there. Population is growing, poverty is growing, land tenure, as I say, fragmentation of land. All these are becomes a kind of driving force, which create, and also on top of that, natural disaster like even though there is a small fragment of land farmer have, and that is taken away by landslide. Okay, so that creates a driving force, and that creates a pressure. Pressure factors are the demand from the different sectors, need for the food, the nutrient mining, all this create a kind of overgrazing that I was talking about. There's a pressure. And all these things will create some kind of state of the land. Land productivity decline state of land productivity, the state of soil degradation, right? Loss of vegetative cover. And then this state will have impacts. Now vast amount of once fertile land is being, the crop yield of those land is being declined. There is a poverty, migration, many other things comes as an impact. So when we are doing response, we need to also see at combined level or some of the level that where you wanted to put your response, whether in the driving forces, adjust your microeconomic policies. Okay, there is a problem there about make a very nice land suitability classification and then make a law that you cannot divide that land in a very uh, unproductive ways. Also, this response can be in a pressure level, do some diversification of income and so on. Also here to do some kind of agronomic trials and so on, how we can really improve the land degradation. So this is just a framework that the policymaker can use. But most important thing is here the sustainable land management has become a very important dimension in order to manage the land at a local level. And we need to adopt to a land use system that through appropriate management practices enable land users. For that, the scientists, the people who are there, the policy maker need to be more proactive. That development must come from within. Very often I feel very ashamed that we go to Africa and other places, we have a Norwegian experience and try to get some kind of survey and so on, and we publish the paper. Of course, we get credit for that, but the homegrown, what are the different kind of barrier which is preventing people to do the right thing at the right time? We need to, that context responsive reality and solution need to be worked out. There are many measures like economic measures depending upon the context, and this has been a lot of money. CGIAR system, other international initiatives, FAO are putting money on finding different agronomic measures, vegetative measures, structural measures, and different management measures in order to find a sustainable land management practices. So these things are very important for to address, to solve the problem at their source, which is more relevant and context responsive. Otherwise, just publishing paper and making good colorful paper and this FAO and these people being a great expert and having a very lucrative high salary is not really helping, I tell you. This is again, so sometimes the economic is also very, very important, that this we need to know about cost of land degradation. How much land degradation means you are really losing money. In Malawi, almost 11% of GDP is lost because of the land degradation. And if you calculate that one in terms of money in different places, you get surprised that this is it's not important, but most urgent thing to do, because there is a huge cost of inaction that you can see in this. If you don't do anything, if you do something, you are losing less money. Okay, but if you don't do huge amount of money, and then you need to do further damage to the earth in order to recover that money. So we need a key area of degradation uh, monitoring. Okay, where are these uh, and where the progress is needed. We still need, science need to improve the procedure, because many countries are also using their own way. I mean, how to uh, how to monitor and how to do data, and you cannot compare. And therefore, the collaboration, coordination, harmonization is also an issue. And also, when it comes to desertification, the indicators, particularly early warning indicators, all these things is also in the early stage. We need to do something about it. So finally, a nation that destroy its soil, destroy itself. No doubt about it. That I have seen in my last 60 years of journey that I am in this world. The places where I used to see a lot of very nice forests, this perennial stream, in Nepal, they have dried out really many places. Mountain desert are also growing. So we need to really bring another insight, another creativity, that forests are our lungs. If they do not breathe, we are not able to breathe really. Also, they are the one who purify our airs and give fresh strength to our people. So more, some kind of, with another lens, with very deep reflective way, we need to look at land degradation, not with the physical, the natural scientist kind of eyes that I have been taught and I have been teaching students for many years. So with this, I thank you all. If there are any questions, you may raise it. But before that, I'll stop the recording so we can be together again. Sam, thank you.